Hello and welcome again. Let's be quick and dive into the Nakama. We want to talk about the match status in this video. If you remember, we had a register match function here on Nakama, and we could give some functions to manage our match there. So those functions are the match init, join attempt, join, leave, loop, terminate, and match signal. I want to dive into each one and describe what you can do with each one in some videos. In this video, we want to talk about the match init and also the state, the important things in your Nakama server application. It's not application, it's game server. So my game is a simple Othello, and I made the front end with React.js, Next.js, and the backend with Nakama. And I'm using TypeScript here. I will dive into Go in the next version, next game. But right now the TypeScript is easier, and I can have a single code for both client and server side. So in the match init, the most important things is that in match init you don't have access to the persons. You don't know who are into your match. So in match init you just need to set up your state. In each function, if you see the Nakama, how you can check the Nakama documentation here, how I check, I go to register match, and I see, okay, register map gets a name and also a match handler. Okay, I click on match handler, and in match handler you will see some functions are here, and you can just define these functions. If you want to know what is the structure of the match init function, you can click on match init, and you will see, wow, there is a function and it's been exported here, and the parameters are this, and also this is the return point of this function. So in the parameters we are getting context, log, and Nakama. These three are static in each function. If you see other functions, you will see that we have these three inputs, but the other inputs are dynamic. For the match init, we have the params, which this params is the params that we are making the match with these params on the making match. I will show you on the platform. If we go to here, we will see in the matchmaker I'm making my match with these parameters, the game mode and the score, and you will be access to these things if you have this match init function for yourself. And also you can submit your required parameters here as a TypeScript type, but I don't use those parameters, so I don't care right now. And the important stuff in each function is the returns. In some functions you have some other returns except than state. See, the Nakama match handler is something stateless, like if we have something like that, if this is our server, so imagine that we have a Othello here, which these two players are playing, and we have another Othello here, and these two players are playing, but both of these are using the same server for connections. And if you remember this, we are using WebSocket. WebSocket is not stateless, it's a stateful, means that we have the detail of previous request and response of the users, and also the state of users in the server. Means that we have the address connection of this user at the server until this user disconnect his connection. We will have those details on our server, and like we in server we can call this user and say, okay, hey Flan, hey that user, we will give you this data. So it would be stateful, means that we have access to user every time that we want. But in stateless, like web applications, we don't have access to the someone who watched the web page. In the servers, we cannot send something to the users except that we connect something like WebSocket. But in HTTP, we couldn't have that. So, but leave it. In here, we have a function called init. So, both of all of these users, there are 4 users that working with this. 4 of these users are requesting to our server and want something to be changed or anything, something, or doing something as a match functions there. And we are registering in a state for each request, or maybe each game. Like we are initting some request for this hotel and another data for another state for this hotel. So how we are storing this, we don't need to care about it because Nakama handle all of that. So how this happens? By these return types. In the each functions, if you see, we are returning the state. The state is static, and every time we are returning the state, this state will be stored in the database of the Nakama, and we will have access to that, which I will show you how it works and where you can see those states. But there are other things in the match init function. There's a tick rate and also a label. The label is optional. You can do whatever you want here. You can make a unique label for the user, and also this label could be used later for joining some users to the match. Like you can even you can check all the matches with label Othello or label what. It's kind of optional, but the tick rate is very important here. What is tick rate? If you work with the game engines, you know that all the game engines has an update function, which will run, which will iterate, and we are writing everything that we want on these update functions. But in like when you are watching a video game that said it's 60 frames per second, means this update function runs 60 times per second. The tick rate is the same. Like if we set the tick rate to 1, we say, okay, you the update function, you have to just run once in a second. If we say 60, it will be run 16%, 60 times per second. So what the fuck is, why this is important? You maybe think, okay, whatever I want, I can put as a tick rate. But tick rate is important when you want to have lots of matches in a single server. Nakama is scalable. You can scale it. You can do whatever you want with Nakama. In enterprise mode, even you can use AWS and scale automatically for you, and everything would work fine based on some states. But if you set your tick rate as the lowest number, like 1, you would be able to handle much more matches at the same time, because the tick rates will be, if you put 60 in your tick rate, each match would occupy CPU 60 times per second. But when you're putting 1, it will but just occupy your server once in a second, and it's very important. So, and also there is another trick here. If you want to track time in your game, you will need this tick rate, and I will show you later in the match loop how we can handle the time. But if we like put our tick rate as a 1, means every time our loop runs, it will be 1 second. But if we put 5, like, my math is not good, it will be 5 times, like each 5, yeah, it will be each time our loop will run once of 5 seconds. My math in English is worse. Okay, but you got my point. We will handle the time here. I will show you later in the loop function. But yeah, so the tick rate is important. In my game, I have an auto logging, so I don't mind if I just put my tick rate as a 1, because it's turn-based and we are just sending the data to the clients. I don't care, okay, once in a second. It's very optimal for most of the turn-based game. In the turn-based, you are waiting for opponents or to do something for you, and everything will be fine. And also another trick that I want to talk with you about is how to have your state in the specific type. We are using TypeScript or Go or Lua, but Lua doesn't have types, but TypeScript and Go does have types, and TypeScript is type version of JavaScript. So we want to have our states to have a specific structure. So I made another file and I just made my auto match state as an interface of the TypeScript. So I did it. You can extend it Nakama runtime to do not have error here. You can extend that, and you can specify your values here. Every type's value that you want here, you can have it, and you can export it, and also you can import it in your application. And when you are storing the state, you just need to specify the type as the state that you have been registered before, and voila. In the next function, you also could have those status. You can have that type there too, and it will help you to prevent some errors with types. So these are the tricks that I want to share with you. First, the tick rate. Second, how the functions and how you can check each functions of the match register in the Nakama. Third is how we can specify specific types for our states, and how the status are works and how the status are stored in the Nakama. But I want to show you another things. Let me just go there, and I have a game here. Let me click on play. Okay, something happened here, but okay. And if I go to my console, you will see my match here, and also you will see my status here, and also the current tick. The current tick and this state will be used in my entire game, and I made some logics based on this states and also the ticks that we are seeing here, and also I'm sending the status to the client, between the client and server. Everything would be fine. I will show you I will show you how to make this auto-log game fully from scratch with Phaser. Oh, it's showing not with Phaser. No, I've been used the React.js for this, not Phaser. And the next we will go to the Phaser. I will show you how to make the auto-log with React.js and Nakama TS in some videos. So don't miss with subscribing to the channel. Don't miss any video. And if you need any help, you will find me. You can comment on the video and ask me on the Telegram. Have a good time.